Important test question on bearing angle. Welcome to our series on test preparation. In trigonometry, bearing angle is one of the most important concepts to understand. In this video, we will understand how do we work with bearing angle, what it is, and also we'll give you a playlist where hundreds of examples will give you in-depth information about how do we solve application questions based on bearing angle. I am Anil Kumar. Welcome to my YouTube channel. Now with more than 400,000 subscribers, thanks a lot. And absolutely free for last 15 years, a learning platform where you post questions and we provide you with solutions. So here is a request from one of our subscribers. The question here is, a boat travels 8 kilometers on a bearing of 135 degrees and then further 6 kilometers on a bearing of 40 degrees, 040 degrees. Find the bearing on which the boat should travel to return directly to the starting point. Excellent question to understand what a bearing angle is and how do we work out the angles. So we'll go step by step. First thing is, what is a bearing angle? Bearing angle is angle from north taken clockwise. So bearing angle is clockwise from north. Also, it is important to understand it is always written in 3 digits. As you can see here, we wrote 040 degrees, not 40 degrees. Mainly because bearing angle is used in navigation. So when you are navigating, especially across the seas, across the oceans, in the space, there could be loss of information. And to make sure that the information received is correct, we know there should be 3 digits, right? So it is kind of a check. Okay. Now let's begin with the question itself. So if you have a question of bearing angle, first thing is you should know where the north is, right? So let's say this is the north for us. And then east and west. Correct. So label north, south, east and west. Boat travels 8 kilometers on a bearing of 135. So that means clockwise we'll go 135. Right? So 90 plus 45. 8 kilometers. Let's say this is 8 kilometers for us. We'll write 8 kilometers. That is 90 and this is 45. This makes 135 degrees from north clockwise. So that is the bearing. And this boat, let's say, it goes from position initial point 0 to A. 8 kilometers. Now, further 6 kilometers on a bearing of 040 degrees. So let's again draw our axis at 8. This is very important, right? And you should know where your north is. From north, 40 degrees. So from north, we'll go 40 degrees, means kind of like this. Let's say this is 6. So let me just stop here. I really don't know. It's not to the scale. So let's stop here, 6 kilometers. But this angle here is 40 degrees. Correct? So this becomes 50, correct? So we have our diagram. We know the position now is, let's say position is B. The question is, find the bearing on which the boat should travel to return directly to the starting point. So directly to the starting point means you have to get back to from where you started. So to O, right? From B to O. Let me connect the two. We want this bearing. So let's draw our axis once again at B. Means we are looking for the angle which is this angle. You get the whole idea. So that is the bearing at which the boat has to travel back to O. Correct? How do we find this angle? So clearly we have a straight line here, means 180, right? Now how much should I add to 180? That is what you're looking at, right? So if this angle is 40, right, and these are two parallel lines, this is north, this is also north, right? So this has to be 40 also, right? Correct? So we know this is also 40. So that comes to this point, but we have to go further. We need to find what that angle is, right? So how do we figure this out? To find that angle, we have to solve the triangle itself. Now, we have to find the inside angle of this triangle. That is the angle which we need to find. Correct? So we have to solve this triangle. We have to find that particular angle. We know it is 180 plus 40 plus that angle. So we will call this angle as angle theta, let's say. So we'll find this angle theta, the angle B, right? Now in this triangle, we know the two sides and which are 8 and 6 kilometers. And we know the angle included. So this is 45. So this angle is 45 and 40. This is also 45, correct? So we know these two angles, which is 45 plus 40, which is 85 degrees, right? And the two sides, 8 and 6 kilometers. So you can use cosine law, since we know side angle side, to find O to B length. Is that clear to you? Right. So we'll use cosine law to find OB. So OB square equals to OA square plus AB square minus 2 times OA AB cos of 85 degrees. Right? Let's calculate this value out. So OB will be square root of this, right? Which is 8 square plus 6 square minus 2 times 8, 6 cos of 85 degrees. So let us calculate this value. 8 square plus 6 square minus 2 times 8 times 6 times cos of 85 degrees is equal to 91.63. So OB will be equal to what? Square root of this, right? So let me write square root of this here. Less space. So we'll do square root of our answer, and that gives us 9.57. 5725. So I'm writing 9.57. So this length we have found as 9.57. So we know OB now using cosine law. We can now use sine law to find the angle theta, which is OBA. Correct? So let me do it here, sine law. So we have sine theta over the side opposite to it is 8 kilometers equals to the angle of 85, sine of 85 over the side 9.57. So we get sine theta equals to 8 times sine 85 divided by 9.57. So 8 times sine of 85 divided by 9.57 equals to 0.8327. It is important to write this in 4 decimal places. Now from here we can get the angle theta. Let me change the theta equals to sine inverse 0.8327, which is, so we'll do shift sine inverse of our angle and we get 5638.38. So angle theta is 5638 degrees, right? Well, the diagram does not reflect it, but still we have our answer. So we can now write down our answer. Now, if theta is 56.38, we can now find the bearing at which the boat should return to the original point, right? So it should be return angle. So bearing at which it will return will be, you see, 180 plus 40 plus 180 plus 40 plus 56 point, we can say 4, right? Correct. So that is what it is. 276.4 degrees. So the bearing angle for return is 276.4 degrees, right, as shown in the diagram, correct? So I hope you have understood these steps. So these type of questions are very much seen in the test papers. So first you have to solve the triangle to find the angle and then work out the bearing angle. Key points here is that every point you should fix the north and then see where you are, and then it becomes kind of simpler. I hope you have understood each and every step. Feel free to write your comments, share your views. Our new book, Crack the Numbers, will be in the market. If you need a sneak peek, write an email to us. Thank you and all the best.
Who is this book for? Middle and high school students who want to go beyond the classroom? Future STEM leaders looking to develop problem-solving and analytical skills? Anyone who loves math and wants to see its real-world applications in AI, physics, and engineering?
Are you ready to explore the mathematics of the future?
Crack the Numbers for future STEM leaders. Sharpen your skills, shape the future. Available soon. Visit our website to pre-order your copy and unlock your mathematical potential today.